Okay, so this was number 8 for the 12th B. So that's another logarithm problem. So like just remember, like we have a property when you have like swap the base and the argument, you take the just the reciprocal, which you can prove it as well. But I'm gonna just use that property. So the log x, like base x of y, is equal to 1 over the log base y of x. So this is the property I'll use. So because they have all the same arguments, so which is why it might be better to that way. So for this one, I'm just gonna write as, let's do cross multiplication as well. So that should be 2 times. And this expression would be 1 over the log base x of 2 plus 1 over log base x of 3. So this is not x squared, this is just the argument. So I should be making obvious. Okay, so this is what we have for the one side, and then this guy would be written as 1 over log base x of 2 and times log base x of 3. So like when you see this one, it doesn't look like helpful, but at the same time, we can make the common denominator for the left side. So that will become, if you multiply this by this guy and then this guy by like this guy, so you will get the log base x of 3 plus log base x of 2. This is going to be product, but the denominator will be just the product, which is the same as this denominator since they are all positives. So we can actually just cancel those, and that is just going to be 1. So now we can combine these two because they have like the same base. So that should be log base x of 3 times 2, which is 6. And then I can divide by 2, so that should be 1 over 2. And now if you convert this into exponential form, so you get x to the 1/2 is 6. So if you square both sides, so you get C. So that was the first problem in terms of logarithm. So we have the second one. So let's do it as well. And then this was number 15. It's kind of interesting because the question asks now the area of the parallelogram where we have only, not the parallelogram, it's just a triangle when we have the coordinates in terms of log, which is kind of interesting. But one of the things that we all probably know about the shoelace, I'm going to use the shoelace with the area for this one. So if I write this, so I will just write log base 2 of 1 and then log base 2 of 2. And the second one is log base 2 of 3 and log base 2 of 4. And I may even write these like 2, and then this is like, maybe I should do that way. So this can be written just, this is 2 squared. I can pull that in front. So that should be just 2. So instead of this, I'm going to replace 2. So this is 2, and then this is going to be 3, and then this is 1. So we can just change those. This is 1. Okay, so we got the 2 points. The last point is the log base 2 of 7 and 3. So when you use a shoelace, we just write the first one as this one more time. So log base 2 of 1, and that is 1. So we just do now multiplication. So these two, these two, these two, these, and these will be multiplied. So if I multiply these two, you got 2 times log base 2 of 1, and then this will be 3 times log base 2 of 3, and then this would be just log base 2 of 7. If I multiply these two, you got log base 2 of 3, and then that would be 2 times log base 2 of 7, and 3 times log base 2 of 1. So when you multiply these crossly, we add these guys together, and then we add these guys together, and then take the 1/2 of the absolute difference. So if I do that, so let me try. So log base 2 of 3 plus 2 times log base 2 of 7 plus 3 times log base 2 of 1. And then we subtract these guys. So minus 2 times log base 201 minus 3 times log base 203 minus log base 207. So we have some cancellation. Let's do that. And like we have base 203. So we have this also. This is 1. This is -3. So that should be -2 log base 203. And then we have 2 times log base 207 minus 1. So that's just going to be 1 log base 207. And the next one, 3, like base 2, these two are the same. So we can get just log base 201. So since these two guys are the addition, we can just combine these together, which will be like log base 207 times 1, which is 7. And then maybe I can write this after than this. So I'm going to do that in the next step. And then I will pull this guy in front like this 2 to the power of 3. So that should be like minus log base 2 of 3 to the second power, which is just 9. And that was plus. And then that's just times 1/2. So since there is a subtraction, we can take the division out of their argument. So that will be like 1/2 times the log base 2. So 7 over, yeah, this is going to be 9 over 7, I guess. Let me double check. So 7 over 9. Okay, so we got them. Okay, but the thing is, this guy is negative. This guy is a positive. When you take the sum, that will be negative, but we cannot take the negative number. So we just need to negate this at the end. Maybe that's why I should have done this first. So I'm going to pull that back. So when you negate this guy, so our expression will become the log base 2 of 7. Actually, I should have this as positive. So that will be like log base 2 of 9 minus log base 2 of 7. So now there is no absolute value. So now we can take the division. So if I didn't do this way, so probably I was going to get this guy instead, which is actually another trap. So then this will be the log base 2 of 9 over 7. But there is a 1/2 in front, so we can pull that as a power. So that should be log base 2 of the 1/2 power of this guy or square root of this one. So which will give us 3 over root 7. So that should be choice B. So there were 2 questions about the logarithm this year, which is sometimes happening. So this was number 15 and 8. I guess they were not too fancy this year, but it was at least interesting to me. So anyways, I'll see the next one.